Welcome to Lesson 7 of Control Theory. Today we'll draw a block diagram from a real differential equation. We'll use the RC circuit model from Lesson 4 as our example. Let's recall the RC circuit equation from Lesson 4. We found that C times dy dt plus 1 over R times y equals U. Here U is the input current and y is the output voltage. Now let's convert this to a block diagram. There are 4 steps to draw a block diagram from a differential equation. Step 1. Identify input U and output Y. Step 2. Remove all derivatives by taking integrals. Step 3. Isolate Y on one side of the equation. Step 4. Draw the block diagram. Let's go through each step. Step 1 is simple. We identify input and output. Looking at our equation, U is the input and Y is the output. This is exactly what we defined in Lesson 4. Check. Step 1 complete. Step 2. Remove derivatives. Why? Because in block diagrams we use integrators, not differentiators. The equation has dy dt, which is a first-order derivative. To remove it, we take the integral of the entire equation. Taking the integral of both sides, integral of c dy dt becomes c times y. Integral of 1 over r times y becomes 1 over r times integral of y dt. And integral of u becomes integral of u dt. Now our equation has no derivatives. Check. Step 2 complete. Step 3. Isolate y. We need y alone on one side, not y with an integral, not dy dt, just y by itself. The other side can have any combination of terms. Starting from c times y plus 1 over r integral y dt equals integral u dt, we move the integral term to the right side. Y equals 1 over c times, open bracket, integral u dt minus 1 over r integral y dt, close bracket. We can simplify this further. Since both integrals have the same degree, we combine them. Y equals 1 over c times integral of open bracket u minus 1 over r times y close bracket dt. This is our final equation form. Check. Step 3 complete. Step 4. Draw the block diagram. We'll build it step by step, starting from the inside and working outward. First, let's set up the input and output. We start by drawing input U on the left and output Y on the right. Draw an arrow from U and end with an arrow pointing to Y. We'll fill in the blocks between them. Look at the equation. Y equals 1 over c integral of u minus 1 over r y dt. The innermost operation is u minus 1 over r times y. This means we need a summing junction where we subtract something from u. The term 1 over r times y comes from y itself. We need to take the output y, multiply it by 1 over r, and feed it back. This creates a feedback loop. Draw a line from y going back, add a gain block with 1 over r. Now add the summing junction. The input u enters normally with a plus sign. The feedback signal 1 over r times y enters with a minus sign. The result is u minus 1 over r times y, exactly what we need. After the summing junction, we need to integrate the result. Add an integrator block with the integral symbol. This takes u minus 1 over ry and produces the integral over time. Finally, we multiply by 1 over c. Add a gain block with 1 over c after the integrator. The output of this block is y. Connect it to the output arrow. Here's our complete block diagram. Input u goes to a summing junction, then through 1 over c, then through the integrator, and outputs as y. The feedback path takes y, multiplies by 1 over r, and returns to the summing junction with a minus sign. Remember from lesson 6, we can combine the gain and integrator into one block. Instead of separate 1 over c and integral blocks, we use a single block containing 1 over c times integral. Both versions give exactly the same result. Version 1 uses two blocks, gain 1 over c, followed by Integrator. Version 2 uses one combined block, 1 over C integral. The feedback path with 1 over R and the summing junction remain the same. Choose whichever is clearest for your application. Notice the feedback structure. This is characteristic of first-order systems with RC dynamics. The 1 over R in feedback represents how resistance affects the time constant. The 1 over C represents how capacitance affects the gain. Let's summarize. We converted the RC circuit equation to a block diagram in 4 steps. First, identify input U and output Y. Second, take integrals to remove derivatives. Third, isolate Y on one side. Fourth, draw the diagram from inside out. The result is a feedback control system where output Y is fed back through a gain block. In the next lesson, we'll apply the same technique to more complex systems. See you then.